This is the first in a series of videos on transformations. First, let's review transformations. You are probably a little bit familiar with them. A transformation will move or change a geometric image in some way. You start with some image, and the original image is called the pre-image prior to applying some sort of transformation to it. Once you have applied that transformation, you create a new image. We call that the image. So the thing you start with is the pre-image, apply a transformation, and then you get an image. Here is an example. The blue figure on the left, this one, gets some sort of transformation, and then you get a new image, the transformed image. Now, the notation, the arrow is very often used to mean I am applying a transformation. So you start with some point name, and then we add this little tick mark, and that's just pronounced prime. So point A becomes point A prime. And if you were to apply another transformation, and that's allowed, you would get a double prime. And you can apply another transformation, a triple prime, and so on. There are several different transformations we're going to look at. I think you're a little bit familiar with most of them. So the first one is called a translation, and it moves every point of a figure in that same distance in the same direction. If you learned about this prior to taking geometry, sometimes they would call it a slide. And one way to remember that translations are the slides are there's a little SL there and there's an SL in slide. So you just basically are just kind of moving it either up or down or on a diagonal, but it looks exactly the same when you're done as when you started. It's just in a different location. A reflection is a mirror image, and we do this over what we call a line of reflection. And there's the same little trick here. There's a little FL in reflections, and there's a little FL in flip, which is the casual name of what a reflection is. We also have rotations, and they turn a figure about a fixed point. And some of the language here may sound a little weird. We say we rotate about a point. You might want to say we rotate around a point, and that's fine, but you just may see it written this way. This point is called the center of rotation, and it's almost like there's a little arm from that center of rotation to every point in the pre-image, and then we rotate each of those points a certain amount. Rotations also sort of can use that little trick. There's a T in rotations. There's actually two of them. And there's a T in turn. Our final one is the dilation. And this is used to reduce or enlarge a figure to a similar figure. It's used to create a proportional image. A dilation will either make an image smaller or larger, but in proportion. So translations, reflections, and rotations create congruent figures, whereas dilations create similar figures. Let's see if we can remember how we can tell what we've got. So I'm starting with a pre-image. That's the blue one here, figure A. Now, which one of these figures of B, C, and D would be the translation? When you translate a figure, it will look exactly the same as its image. It's in a different spot. And if you look at all the different ones here, the only one that is exactly the same as our original is B. I should say triangle B, because it's in the same orientation. Everything is the same. It's just in a different spot. Now, the reflection will be a mirror image. So if you could fold along a line on the paper, and if you were to take, say, maybe put some ink along this triangle A and then fold, you would get a stamp on the other side. And the figure that best reflects that would be this guy right here, triangle D. And then which figure is a rotation? So a rotation is turning in a circle about a point. And for our purposes, we're always going to go about the point 0, 0, the origin. So if I want to see one about this one, if I were to rotate it around some way, which one would I get? So if you move it in a circle, it's triangle C that kind of shows A being upside down. It was rotated to that upside down position. Let's see if we can identify these transformations. So what would this be? Well, I see this line H and I see this little arrow here saying, hey, it's being flipped around there. And it is a reflection of the original figure, the blue figure, if you fold it along that line H. So reflections, I'm always thinking about, you put some ink along here, you folded a piece of paper, and what was the image that resulted? So we reflected over this line H. This one, again, blue is our pre-image, red is the image. We turned this figure a certain number of degrees, and so this would be our turn or our rotation, and we rotate it around this point P. This one, it looks exactly the same, the pre-image and the image. It's just that we moved it. So that would be a slide or our translation. And then this one, our pre-image here, was a certain size, and now that image is bigger. So this would be our dilation, and we enlarged it in this dilation. Let's talk with a little more detail about translations. Translations, once again, they're going to take the pre-image points of some image on the plane, and it's going to take each of those points and move them the same horizontal and vertical units. So same way left or right, same way up or down. They form what are called isometries, and I'm not even sure I'm pronouncing that right, but all that means is the pre-image and the image, the thing you come up with, will be congruent to each other, so they're going to look the same. The rules describing horizontal and vertical changes are used to help you make translations. Let's look at an example of what we mean by rules. I've got a quadrilateral ABCD, and these are the coordinates. A is -1, 2. B is -1, 5. C is 4, 6. And D is 4, 2. So we're just going to go and graph those. So -1, 2. So this is point A. B is -1, 5. And that's B. C is 4, 6. And D is 4, 2. And we can make the quadrilateral by drawing the segments between these points. And there it is. So quadrilateral ABCD. So we want to find the image for each vertex after doing this translation. So here's what a rule format looks like. For each XY in the pre-image, you are going to transform each value by adding 3 to the X and subtracting 1 from the Y. So we can do the mapping from each of these points. So I'm going to make my little arrow, which means transform, and I'm going to have now an A prime. And I'm going to add 3 to the X value. So -1 plus 3, that's 2. And then I'm going to subtract 1 from the Y value. So 2 minus 1 is 1. And that's my A prime. B will go to B prime. And I'm going to add 3 to the X. So still -1. So when you add 3, you get 2. And then subtract 1 from the Y. The Y is 5. So that becomes 4. C prime. Add 3 to its X, you get a 7. And then subtract 1 from the Y, you get 5. And then D prime, add 3 to the 4, still 7. And then subtract 1. And then this is what we're going to graph to get our image. So let me change the color so we can see it a little bit better. A prime is at 2, 1. And that's A prime. Putting my little prime in. B prime is 2, 4. And that's B prime. C prime is at 7, 5. C prime. And D prime is 7 and 1, which is over here. D prime. And then we'll join those segments. And they should look congruent because they are congruent. And you can do this point by counting boxes. So this basically, if it's a plus, you go right. And if it's a minus, you'd go left. If this is a plus, you'd go up. And if it's a minus, you go down. So from any point, it doesn't even have to be these vertex points. I'm going to pick the point right over here. And if I go right 3, 1, 2, 3, and down 1, I get to its matching point in the image. And so you can do it that way, but I would like you to get used to working with the actual transformations by making this sort of a mapping. And that's our first example. There's another way to think about translations. It really means the same thing. You do all the same thing, except where it introduces the concept of what vectors are. And you may recognize this guy here. If we were actually in class, I would show a little clip from the movie where he talks about himself. This is from Despicable Me. And he calls himself, I'm vector, and I have direction and magnitude. And that's what vectors are. They are mathematical ways of describing a direction and a size. That's what we mean by magnitude. When I'm looking at this picture down here, you start at an initial point. So I'm starting here at, say, F, and I want to get to point G. And the way vectors work are you think of a horizontal and a vertical way to get there. So you would go 5 units right, you'd go 3 units up. And the way you find the magnitude of FG, we do get a little right triangle when we think about horizontal and vertical. Then the magnitude, the size associated would be the length of this. So you could use Pythagorean theorem. And vectors are a very big topic in mathematics. We are only just defining it really here and using its characteristics to describe translations we might want to make from one figure to another. The way we write a vector is this, and that's really hard to read. It looks a bit like a ray, but there's only kind of one little arrow piece to it, so it's not a ray, it's a vector. It's easy to confuse them because they do look like the same thing. But it's basically saying you start at F and you go towards G, again, like a ray. And how do we do that? You write it, these look like coordinates, but they're not quite coordinates like X, Y's. They are describing horizontal moves versus vertical moves. In the example I have below, I've got vector 5, 3. So notice these are not parentheses, they're sharper. They're little brackety things. If this number is positive, it means go right. If this number is negative, it means go left. And the second number, if it's positive, it means go up. And if it's negative, it means go down. Start at point F, go right 5, and go up 3. So you start at point F, you go right 5, and then you go up 3. And there is our direction. And again, that magnitude would be use the Pythagorean theorem to find its length. Let's practice a little bit naming vectors and putting it in their component form. Here's a vector. I'm starting at point B, and I'm going to point Z. So if I'm going to write vector BC, I'm going to have these little sharp brackety type parentheses. What is the horizontal move? How many boxes do I go right to get there? 9. And then how many do I go down? I go down 2. Going down is a negative direction. So BC, that vector, is defined in component form as 9, negative 2. Our second example, it's a little hard to see. My arrow's going this way. So where am I starting? I'm actually starting with S. So this is kind of like with rays also. Even though we're kind of going in this backwards way, you start at the start, and that's at S. And then you move towards, this is actually a T. Hard to see that. Then you move towards T. So this is vector ST, even though it feels like you're reading it backwards. And in vector form, when you're at S, we actually are going left now. How many? 8. Left 8. So you use a negative sign to say go left. Now, how many up or down am I going? I'm not going up and down at all. I'm staying at that same level. So that would just be a 0. When you use vectors with translations, it's just an alternative way to say, how do you transform each point? We have a triangle ABC, and here are its points. A is 0, 3. B is 2, 4. And C is 1, 0. This is the same as having a rule that says for each xy, transform it by starting at x, and in this case, I'm moving right 5, so you add 5, and then your y, you're going to subtract 1 and go down 1 from that y. These are equivalent ways of saying the same thing. So this is a little bit shorter. My A prime says add 5 to the x, starting with 0, so that'll be 5, and then subtract 1 from the y. So since this is 3, subtract 1, you get 2. B prime, add 5 to the x, which is 2, so that's a 7, and then subtract 1 from the y, which is 4, so that's 3. That's B prime. And then C prime, add 5 to the x, so it's at 1, so it becomes 6, and subtract 1 from the y value, which is a 0, so that becomes negative 1, and that's what we're going to graph. So let's graph our first pre-image triangle, label points. And then if we graph our image points, A prime is at 5, 2, that's A prime. B is at 7, 3, B prime. And C is at 6, negative 1. Join those together. And there we have it. That's kind of all there is to talk about for now on translations. So I want you to try these two. There's 2 examples on this page, and then there's one on that page. So if you have hard copy of this, if you're one of my students, go ahead and work them. If you don't, just look at the screen here. But everybody should be pausing their video right now so that they can do these U-tries and then see how you did. So go ahead, give it a shot. And we are back. What you should be doing is actually mapping these out. So PQR, they're the same in both of the examples here. We're going to first just maybe put our preimage in. Then you have to kind of write down, well, what are the new values? What are the translated points? So P prime, trying to find a little space here. For the first one, you're adding 4 to each x and you're adding 6 to each y. And this is using the rule format. And if you want to change this to a vector, you can. It just becomes 4, 6. Whichever one you're more comfortable with, doesn't matter. So P prime, we're going to add 4 to each of the x's. So -2 plus 4, that's 2. And then we're going to add 6 to each y. So 3 plus 6, that's 9. Q prime is, let's see, add 4 to the 1. That becomes 5. Add 6 to the 2. That becomes 8. And R prime, add 4 to 3 is 7, and then add 6 to the y, -1 plus 6 is 5. And then we can go ahead and graph that one. And that would be the first transformation. The second one, maybe I'll do that one a slightly different color. So the second one there, maybe I'll call it P double prime just to maybe avoid confusion. I'm given this in vector form. And if you prefer rule form, it's very easy to transfer that. So it's xy goes to x minus 2, y minus 5. You go left 2 and down 5 from each point. So if I'm starting with this guy, -2 minus 2, that's -4. And then 3 minus 5, that's -2. My Q double prime for this one, which is -1. 2 minus 5 is -3. And then my R double prime, starting with 3, we subtract 2, that's a 1. And then -5 minus 1, that's -6. Boy, that's a little hard to read. So let's see. So then we graph these, and that would be the image for that particular vector. They're asking you for what translation did we make? And they want it both in vector form and rule form. First, figure out, well, what actually happened. So find some matching points. Be careful here. There's no hard and fast rule who gets the solid line and who gets the dashed line in terms of pre-image or image. Look at the actual point names. So this one is A, and this one is A prime. A is my pre-image, and I did something to A to get to A prime. Well, what is that thing I did? Well, I went left a certain number of units. 1, 2, 3, 4, 5. So I went left 5 units. And then from there, I went up 1, 2, 3. So if I'm writing this in rule form, we start with any xy in the pre-image. What do we do to the pre-image points? Well, we went left 5, and left is a subtract direction, so we subtract 5. Then we went up 3, and up is the positive direction, so we add 3 to the y. And that's the rule form. If you want this in vector form, not that difficult. You just look at what you do once you're at the point. You go left 5, and then you go up 3. Let's look at the second one. So again, don't go by who's solid, who's dashed. Just look at the points. Here's A, here's A prime. A is my pre-image. Well, how did I get to A prime? Looks like I went right 2, and then I went down 5. So in rule form, for each xy in my pre-image, I want to go right 2, so I'm going to add 2 to the x value, and then I want to go down 5, so I subtract 5 from the y value. If you know the rule, it's easy to get the vector, and vice versa. If you know the vector, you can get the rule. You start at a point, you go right 2, and then you go down 5. And that is what I have to say about translations. Hope it's helpful. Thank you for watching.